Hello everyone and welcome to The Motion Master. Today we're diving into the topic of momentum and collisions, which is the physics behind car crashes, spore hits, and even rockets. Let's get started. So, first of all, momentum is what tells us how much motion something has, and it depends on two things: how much mass it has and how fast it is moving. The formula is this one, where P is equal to momentum and is measured in kilograms times meters per second, and the mass, which is measured in kilograms, and velocity, which is measured in meters per second. So, okay, let's imagine that a small car, and a truck move at the same speed. The truck has much more momentum because it has a lot more mass. Actually, let's say this ball, which has a mass of 2 kilograms, rolls in this direction with or at 3 meters per second. What would the momentum be? So the formula tells us that the momentum would be the mass times the velocity, or it would be 6 kilograms per meter squared. Sorry, meters per second. So that would be the mass. Now, okay, this is called the law of conservation of momentum, and it says that the total momentum before the crash is equal to the total momentum after the crash. This is the formula, and this is one of the coolest laws in physics. It says that total momentum in a system stays the same no matter if an external force acts on it. So imagine two cars bumping into each other. The total momentum before they collide is equal to the total momentum after. This means that momentum is transferred between the objects, but the total amount doesn't change. Okay, so we have two main types of collisions. These types are elastic collisions and inelastic collisions. Now, in elastic collisions, objects bounce off each other, and both momentum and kinetic energy are conserved. So, for example, we have two billiard balls in pool that we're gonna bump into each other. They bump, and they are you know repelled, and they are moving in opposite directions. So they bounced. I'm sorry. And now in an elastic collisions, objects stick together after the collision. Momentum is conserved, but kinetic energy isn't, like in a car crash, for example. Okay, so basically, momentum shows up everywhere. In sports, players lower their speed before a collision to reduce momentum. In cars, airbags spread out the force of impact by increasing collision time, which lowers the force. And you know, force is equal to the sum of momentum over the sum of time. So this formula shows what I just said perfectly. If you increase time, the force decreases, and that is how safety features can save lives. Now, a quick challenge. Okay, if I have a mass of 4 kilograms and a velocity of 5 meters per second, what would what would the momentum be? So 4 times 5, that would be 20. So 20 kilograms times meters per second. That is our momentum. And that would be momentum and collisions. So thank you, and see you next time.